Hello, hello, hello. Good noon, fine internet. Oh, there we go. Spin that around. Great. Let me get my headset. Boot this guy up. There we go. Good morning, everybody. Look at this delicious, delicious, appetizing glop that I have here. Do you see what this is? Do you see what this is, Twitch chat? Oh my word in heaven. Only just yesterday, I was talking about my tea has spilled a bit. Only just yesterday, I was talking about mushy peas on stream. I mentioned that one, right? And like minty mushy peas, which, for the record, like mint with peas, I don't know. It still doesn't sit well with me. But I mentioned that I had some split peas on to soak. Well, here, this is the finest of Newfoundland delicacies right here. Well, maybe the second finest. Cottagratton's pretty good too. Toutons are good too. Maybe this is the third. I don't know. Maybe I'd put pea soup over Toutons. I don't know. But this here, this like vaguely baby poop looking thing, this is delicious. That is a bowl of split pea soup that I cooked with. This is my, social distancing sort of cooking, right? Where I'm breaking out all the random stuff in the back of my cupboard. So I happen to have some split peas back there. So I went ahead and soaked them overnight and made a small pot of soup out of it. Didn't have any salt beef to put in it or salt pork. You gotta have salt beef or salt pork, right? So what I used was the very last little bit of some quite nice, like charcoal smoked pulled pork shoulder that I did. Mm. Smoked it over lump lump hickory and apple. Because again, I didn't have enough of either to do just that, right? But it's yeah, it's nice. It's a nice soup. Show food on stream. Mm-hmm. That's how we do it. That's how the pros do it. They just sort of eat on stream, mute the mic, and then just sit there. That's good. That's good content, let me tell you. That's 6 minutes of being live. And I've gotten 2 spoonfuls into my lunch. All right, we're going to have to put lunch on hold for a little bit whilst I get into talking about the various topics that we are going to cover today. Oh, also, yeah, right, I treated you to a wonderful. See, there's my my DIY boom cam. Look at that. Isn't that? Yeah, that's good stuff. Anyway, so I was treating you to a little picture of the furry people over here. This is that's Smokey. There, he's the brown guy. He's Belgian Tervuren and Irish Setter and a whole bunch of stuff. And this is Flurry. She's Lab and Husky. They're both rescue dogs from the SPCA in Goose Bay. So if you're anywhere in Newfoundland and you want a dog, that SPCA and Goose Bay are the ones to talk to. They get more puppies and objectively more adorable puppies than anywhere else. That's just true, right? It's like I tell my students, right? Everybody in the world thinks that their pet is the best pet in the world, but they're all wrong because my pet is the best pet in the world. All right, that's just truth. Oh, there we go. There we go. I backed me up on that one. Good morning, though. Jasper is. Oh, I don't know. I don't know. You're gonna have to tell you what. Tell you what. Once I get my Twitter up and running, you'll have to at me and with some proof that Jasper's the best pet in the world. Okay, right? But it is actually up NL Math Man. I haven't tweeted on it yet or anything, but it's just on tweet whatever it is. Twitter.com/nullmathman. Okay. So for today, we see here we've got quite a few topics to get to. Um, I am going to get to them in roughly this order as well. Okay. So again, right, if you're one of my students or one of the students from, say, the Kenmount campus of Academy Canada or any other satellites or Corner Brook, welcome very much. Super glad to have you. If you make a free Twitch account, you can drop some messages into chat. We'd love to hear you hang out a bit and, maybe can feel more like we're on site actually teaching. Right? Well, I am actually teaching, but I mean actually, in a school, as opposed to at home drinking a giant mug of tea with 2 tea bags on it. See? And with your free account, if you make one of those, you can also get messages. Just checking in. Thank you, Brittany. Thanks for checking in. Um, yeah, I'm not going to be recording who checks in my stream and who doesn't, just because that's it's sort of a ephemeral thing. It's kind of just here to hang out a bit. But do please send Jennifer or myself an email if you're trying to check in for your attendance. Okay. Now I'm going to grab some blank paper. And yes, if you make a free Twitch account, you can send me messages while the stream is going about any sort of topics that you want me to get to. Doesn't matter what to, doesn't matter who, I think you mean. No, you can send it to both of us. I mean, you can just stick both of our names there in the CC. But do please mention what you're currently working on as well. Part of the point of the daily check-in is so that we can get updates on what courses you're doing right now, so we can sort of keep tabs on that and make sure to offer sort of relevant suggestions as to what you can be doing. Right. So for today, then, like I said, I'm going to start off with Math 2101A, lines and angles. Now we can see that up here in the corner. Right? So it's a touch blurry. This is from a textbook that I don't have I don't have a digital copy of this guy. So that's just a picture taken of the page in the book. So bear with me a little, but I think you can see that pretty decently aside from the tiny little bit in the corner there. So this is the first thing that I'm going to be going over today. So let me just move this stuff over here because that'll be my to-do list so I can know what I've gotten to today or not. So let me take another delicious spoonful of split peas. Look at that. Look at that. Split peas, onions, carrots, pulled pork. Mm. Oh, it's warming. It's really good. I like it. It sort of soothes and warms on the way down. Oh, it's good. Nope, Bert. No, I've got your attendance there. You have checked in, so thank you very much for that. So, I am on now. This is Math 2101A, lines and angles. Okay, let me just move my mic back a bit so we can see my nice DIY haircut. Math 2101A, lines and angles. So, this is question number 5. Right? Let's see. Actually, tell you what, I'm going to hold off on this one for a brief bit because the student who suggested this one to me hasn't chimed in chat yet. He was here yesterday, so I'm just gonna put a pin in that one actually. If our friend Captivating Cacti shows up, I will switch back to that one and cover his question because that was one that he had. To start off, then I will go with let's see here. Let's go on to the next one. Let's do the Math 3101A Venn diagrams first. Now, if you haven't done this course yet, this is still a really good topic to sit and watch because this one's a bit different than the other topics. Like Venn diagrams are covered in Math 3101A, which is the first of the grade 12 academic. But oftentimes people haven't covered that before because there isn't really like a prerequisite part that goes over these ones. So even if you're not on this course right now, this is a super good one to just, carry along with and watch me go through some examples of. So the student asks specifically for questions. Let's see here. I believe these were from let's see. Who were these questions from? Yes, they were from Ahmed at, I believe, at the Kenmount campus. Hello. I believe I do remember you from my time teaching at ChemMount. So good to have you on board. So we're starting off with question 3 here. Consider the following sets. All right, let me zoom in a little bit so you can see that a bit better up here in the corner. Let me check OBS. How are we looking? Looking good. Looking good. Okay. Continue zooming in. Come on, PD. There we go. Consider the following sets. A is okay. First up, I'll go over why the notations are written like this. The following set. So the set A is x. X is less than or equal to 12. X is prime. Right? So, why is this first x here? Why is this like x and then this bar? What's that about? Well, this is telling us that x is the value that we're looking for. It's not super relevant right now, but you will see in some examples later, there can be multiple variables in your same set notation. So say if you wanted your set to skip numbers, what you could do is you could say that your set S is going to be X, but then X equals 2Y, and then Y could be less than, let's see, Y could be actually, I'll write it out a bit better. 2 is less than or equal to y is less than or equal to 6. Y is integers. Right? I sort of crammed that on the side of the page here, but this is just an aside. It's another example. Right? So if we were to do something like this, y could be the numbers 2, 3, 4, 5, and 6, but then x would be the numbers 4, 6, 8, 10, and 12. Right? So that would make 8, 4, 6, 8, 10, and 12. Right? But this is just sort of a little aside over here to explain what this notation is actually standing for. Right? But here, we don't have 2. But that's why this x before the bar is here. That's to tell us that x is the value that we are looking for. But so x is less than or equal to 12, x is prime. So we need to now know what values that's going to be able to take. So what are the prime numbers that are less than 12? Well, that's something that you're just going to kind of have to know offhand, right? But it's going to be, so here x can be 2, x can be 3, x can be 5, x can be 7, x can be 11, and that's it, right? Now, prime numbers are, of course, numbers that can only evenly be divided by themselves and 1. Super important term. You're going to see it come up a whole bunch in a whole lot of different courses. Interesting piece of trivia that sometimes they'll try to trip you up with is that there is one even prime number, and that even prime number is 2. It's only 2. Because every other even number can be divided by 2. But, I mean, 2 can be divided by 2 as well, but 2 is 2, right? And the qualifications for if something is prime is that it can only be evenly divided by itself and 1. And since 2 is itself, it is a prime number. So 2, 3, 5, 7, and 11. So then set B here in our example is dealing with x. 1 is less than x, is less than or equal to 10, and x is even. Okay, so the even numbers that are greater than 1 and less than or equal to 10, so here x is going to be 2, 4, 6, 8, or 10. Right? So now what we're doing is determining, what we want to find is the number of A or B. And we read this as or. Some people read this as union. I always like to read that as or. Right? So what we're trying to find is the number of elements that are either in set A or in set B. Right? So I'm going to draw out a bit of a Venn diagram over here, and I'm going to break out some of my RGB. Look at that. Look at that. Colors and sound effects. So set A, I'm going to do in green. Excuse me. It's going to be here. Set B, I'm going to do in blue. That's going to be over here, right? And then the overlap, I'm going to put in the middle. I'm going to do them in red. So that's going to be a set A and B is how we read that guy. A and B. Okay, and let's see, I'll spice this up a little bit with some red out around so we know exactly what's going on here. Look at that. Okay, my coloring skills are not great, but I don't teach primary school. So over here, we know that the values that are in A, well, let's look at the ones that are in A and B over here, right? And I'll just circle them with red because that's what I'm using. So 2 is in A and B. We got that guy. And then 3, 4, 5, 6, 7, 8, 11, 10. Nothing else overlaps, right? So 2 is going to go right here in the center. Then the values for A are going to be 3, 5, 7, and 11. Right? And then the values for B are going to be 4, 6, 8, and 10. Right? So all the values that we have from these sets are in these Venn diagrams someplace. So what's our number of A or B here? Well, our number of A, let me just show you here. The number of elements in A. We don't necessarily need to do this to solve this question, but it's a good teachable moment, so I'm going to veer off to the side a little bit. Number of elements in A is 5, right? 1, 2, 3, 4, and also 5, because this one is also in A. The number of elements in B is also 5, because it's 4, 6, 8, 10, and then also this 2 over here. So this 2 is also in B. So the number of A is 5, the number of B is 5. But does that mean the number of A or B is going to be 10? Does it mean that? No, it doesn't. It does not mean that. Why doesn't it mean that? Well, we can go through and count. We can just go and count the numbers directly off of here and then see 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Why is it 9? Well, it's 9 because the number of A and B is equal to 1. That's this 2 in here. And if we count the number of A as 5 and the number of B as 5 and then add those guys together, we're actually counting this 2 twice because this 2 is in both sets. So this is why the number of A or B is equal to the number of A plus the number of B subtract the number of A and B. Because this guy here, it would be overlapping, right? So, and this is true for probability as well. Like if you've got several events, like anything you measure in a Venn diagram can kind of be covered through this, right? Yeah, this could be P, A, and B instead of N, A, and B, right? And it would work exactly the same way. The rule is the same. So here we're going to have 5 plus 5 minus 1 equals 9. Or like I mentioned, you can just straight up just count it off your diagram. Okay, so the number of A or B is 9. Right? And this is the kind of workings that I would expect to see. Everything here. Let's see. I'll put this in a bubble too. Because it says show your solution using a Venn diagram. See that right over here? It's show your solution using a Venn diagram right there. Because it says that, I would expect on a test or an assignment to see everything here aside from what's in these two bubbles. So this and this. Okay, next question. Also wanted to go over, oh my God, my allergies are brutal. Nose is so itchy. Got to get more antihistamines. Boy. Number 9, here we go. In a school of 120 students, the following was found. 5 students took English, physics, and chemistry. 15 students took physics and English, blah, blah, blah. James summarized the data using the Venn diagram shown. This guy, this one here. Identify the regions in James' diagram that have errors Describe the errors that he made. All right, so we're going to need to zoom out a little bit so that you guys can see it. Oh, that's in. In and out are different words. I need to listen to Grover a bit better. Here? My Grover impression could use a bit of work, maybe. I do love public access TV though. That's my jam. Seriously, PBS, NPR. Well, that's not. It's radio. But Twitch is kind of like that. Which is kind of like a combination of those things. At least for me, it is. I'm quite pleased with that. Anyway, digressing. So this is math. We're still on 3101A. And it's still on Venn diagrams. Okay. So James made this diagram. So 5 students. I'm actually going to copy some of this over. Actually, tell you what. I'm going to use some of my fancy technology here. Let's do that, and then let's do this. Hey, there we go. Okay, yeah, that's more like it. There we are. Good stuff. All right, so now we should be able to read both at once. Actually, let me center myself. There we go. There we go. Yeah. Now I'm kind of centered, aren't I? Hey, look at that. We're doing it. We're doing it live, boys. We're doing it live, boys and girls. We are doing it live. Twitch chat. There we go. So, 5 students took English, physics, and chemistry. So, 5 students took English, physics, and chemistry. Right over here. Are we seeing my cursor? We're not. Oh, now we're seeing my cursor. There we go. So 5 students took English, physics, and chemistry, which is why there's a 5 down here right in the middle. 15 students took physics and English, so they got 15 up here. But hold the phone. Hold on a second. But this whole area here, this whole sort of almond-shaped area, this is the part that's the section that's physics and English. But look, there's a 15 here and a 5 here, which means our dear friend James went ahead and put 20 people doing physics and English. But we're not told it's 20, we're told it's 15. So there's your problem. There's your problem. Let's see if he did the same mistake a few times. 8 students took physics and chemistry. Well, he's got an 8 here and a 5 here in the middle. So then it's going to be 13. Brittany, would, just one sec there, please. But would 34 plus 79 equals 13 be an algebraic expression? That is not an expression, no, that is an equation. The difference between an expression and an equation is that an equation has an equal sign on it. That's the root of the word, right? So even if there's no variables there, I see what you're saying, that because there's no variables, maybe it's an expression. That's a good guess. But the point is that there's an equal sign. If there's no equal sign, it's an expression. If there is an equal sign, it's an equation. Okay, but yes, to go back to James's mistake here, he also said 10 students took English and chemistry. He's got a 10 here, but he's got a 5 here, so he's actually saying 15. 15 took English and chemistry. All right, so there we can see a little bit about what James's boo-boo was. So let's go and make a correct version for him. So I'm going to do, let's see, red circle, boom, green circle, boom, and blue circle, boom. Yes, I get my broadcasting skills from mostly Strong Bad Email, hence all the sound effects. It's more archaic internet references for you. I love it. It's good stuff. So over here we've got English. We have got physics. And we have got chemistry. So we have been told that 5 students took all 3, so I'm going to put 5 in here. Right? What do we call that 5? Well, that 5 is going to be the number of English and physics and chemistry, right? So just to show you as a bit of an aside that we can have multiple sets that have unions, right? So this is a union of three sets, totally fine, totally valid to have that. So then English and physics together is supposed to be 15, right? But because it has to be 15 in total for this whole, like I said, this whole like almond shape thingy, it's actually got to be 10 out here, right? So 15 is equal to the number of English and physics, but we would say 10 is equal to the number of English and physics and not chemistry, right? Again, you won't have to know this sort of notation, but this means not, right? So this section here, this one there like that, that's English and physics and not chemistry. By the same token, right, we're going to have, say, 8 took physics and chemistry, which means we're going to have a 3 here. 10 took English and chemistry, which means we're going to have a 5 here. And just to keep on writing out these guys, right, we have 8 is equal to the number of physics and chemistry, but 3 is equal to the number of physics and chemistry and not English, like that. Hold on just one quick sec. Okay. Next up, yeah, I won't write out all of these guys, but the rest of these now will be a little bit more straightforward, right? So we have 99 students took English. Okay, hold on a second. We have one more wrinkle in this guy. We've got 45 students took chemistry, right? So 45, all of these numbers and this one, this x, have to equal 45. So we know this is 5 and 5 is 10, and 3 is 13. 45 minus 13 is 32. So we know that there are 32 out here in our chemistry. And we could say 32 is equal to the number of chemistry and not English and not physics, right? So in other words, 32 is the number of people that are taking only chemistry, right? And say for physics, we know that 30 are taking physics in total. We have 18 taken care of here, so we know that 12 are going to be over there. Now we've got one last little wrinkle in this question, and that's when it's saying 99 students took English or chemistry. So what does that tell us? Well, it tells us that this number here, this x, right? If, let's see, English or chemistry is equal to 99, what that tells us now is that this x over here, right? So all these sets basically, this one, this one, this one, this one, this one, and this one, all those added together exactly one time are going to equal 99. So this x plus 5 plus 5 plus 10 plus 3 plus 12 equals 99. All right, so now it's just, now once we've got this down to here, this is just math like you've seen, you know, dozens, hundreds of times, right? So this is 10, 20, 23, 35. So x plus 35 is equal to 99, or then x equals, what is that, 64. X is equal to 64 because 99 students took. Oh, my mistake. My mistake. Look at that. Look at that. Aha. Ah. Hopefully some of you sharp-eyed people in chat here caught that. Caught that. But I was making a mistake. They're making a boo-boo. It's actually English and chemistry. I was doing English and physics. Oh my goodness. My goodness. Never mind. You see? Especially, anyone makes mistakes, especially the teacher. All right. So, draw an S and then a more different S. Yeah. It's another reference that exactly like 0 people are going to get. 5, 5, 10, 3, and 32. 5 and 5 is 10, 10 is 20, 23, 23 and 32 is 55. There we go. This looks like more like what it's supposed to be, right? I got there. We'll get there, you know. That's the important point, guys. Checking this stuff over. Always check your work. feels like a pain at first when you're like, oh, I just want to get this activity over with. But I mean, checking it over, that's the difference between like an 80 and a 95. And I mean, 80 is a fine mark. We take those. But, you want to be pushing for it, right? You want to be getting the best you can. So then we have, uh, well, oh, my goodness. See, I'm doing it again. 99 is still what it equals, but this equals 99. See? I'm trying to do too many things at once. Oh, yes, Ahmed, you're very welcome. Yes, I'm glad you stopped in live. So this, yeah, and please let me know in the future if you've got any other questions. You know my email address. Yeah, just let me know if you want anything to go over. I'm sure your teachers at Kenmount have their own sort of policy for testing and all that. But if you're working on any review like that or any of the notes, I will absolutely help you as best I can. So that is 20, so that is 55, yeah. So x plus 55 is equal to 99. Don't mind me, I'll get there in the end. X is equal to 44, right? 99 minus 55 is 44. That makes sense. All right, there we go. We got there. We did it. We did it, Reddit. Provide a correct Venn diagram for this info. Done. How many people did not take either of the three subjects? Ooh, how are we gonna know that? How are we gonna know question C? Who did not take any of them? Well, we know that the total number of students is going to be 120. And then, well, what's the total of all these guys here? Well, I'm just going to break out my good pal TI-84 over here. We're going to go 44 plus 10 plus 15, sure. Plus 15 plus 5 plus 3 plus 32 plus 12. Gets us 111. Right, so there's 111 in there. So we're just going to be 120 minus 111 equals 9. So because the question told us in the school 120 students, right, up here, oh, my cursor keeps disappearing. Come on. There we go. School of 120 students, right? Here we're accounting for 111 of those, which means 9 are going to be left over. So there we go. That is Math 3101A, done real. So let's cross that one off the old list. Ah, what an apt what an apt emote to use. Captivating cacti. I am yeah, definitely I'm like Bob Ross doing math. Oh, please don't flatter me. I mean, you didn't say that. I said that. So I mean, I'm not flattering myself. It's just kind of like, but I do love Bob Ross. It's definitely an icon of public broadcasting. And I grew up on like a steady diet of PBS stuff. Let me tell you, like Mr. Rogers, like I'm even dressing like Mr. Rogers. And then LeVar Burton in Reading Rainbow. Boy, oh boy, I love Reading Rainbow. LeVar Burton is like almost single-handedly responsible for the fact that I'm a sci-fi nerd now. Because like I saw that episode as a kid of Reading Rainbow where he's on the set of Next Gen. And yeah, it just like blew my mind wide open. And then I just started watching that show because hey, the guy from my reading show is on this. Hmm. I mean, also, mom and she has all these had all these Isaac Asimov books downstairs and stuff when I was a kid, and I did see those. So there was also that too. All right, so Captivating Cacti has dropped into the chat, so I am now going to go ahead and get back to this Math 2101A. So here we are. Straighten up my sheets. Math 2101A. What is this? This is, we'll call this lines and angles. Okay. So in each diagram, is AB parallel to CD? Explain how you know. Now this is a fairly quick question. right? But just the way that we can tell if it is or not is simply because of these. Are you seeing my cursor here? We are. Okay. You see here, these two lines look like they're parallel, but we're not quite sure. So let me get my math set. Let's do it out. Let's do out some lines. Usually when a teacher says let's do out some lines, that's it's a punishment, right? You got to write the same thing over and over again, like Bart Simpson on the chalkboard. All right, so here we've got another line coming down for a transversal. Now, what a transversal is it's a line that crosses another line, right? So this is our transversal, right? And we're told here now that this angle is going to be 57 degrees, and that this angle here is going to be 58 degrees. And we know that if this line was parallel to this line, that means they will never cross, no matter how far we go in either direction. We could keep extending this one infinitely that way and that way, and this way and this way. And if they were parallel, they would never ever cross. But if there's any difference in angle at all, any small difference, then they're not parallel because eventually they're going to cross. And here we see this is 57 and this is 58. Those angles are different. If the angles are different, they are going to cross. So that means they are not parallel. So this one is not parallel. All right, rather than drawing the diagrams again over and over, I'm just going to tell you what, I'm going to continue these lines. Continue them across like this. Okay, good. And now let's do, let's just switch color. Let's do part B. Part B over here in blue. So part B, it kind of looks like this. And in B, we've got this angle is 86 degrees, and this angle is 94 degrees. Now, are these ones parallel? Well, what do we know? What do we know about these angles? Right? Well, there's plenty of ways to solve these questions, so I'm not going to tell you like exactly one thing to look at, but in general, as long as you know how angles around a point work, you're going to be able to figure these out after a little bit. So, if this angle here is 86, what's this angle over here got to be? Well, we know that a straight line is always 180 degrees, right? Straight line equals 180 degrees. So that means this line over here has got to be 180 minus 86. So 180 minus 80 would be 90, would be 100. 100 minus 6 is going to be 94. Oh, so that's the same as this one. How about we figure this one out? Again, this has got to be 180, right? So that means this one's going to be 180 minus 94, which is again going to be 86. So this angle is the same as that angle, this angle is the same as that angle, which means these ones are parallel, right? So we either need this angle and this angle, to add to 180. That means they're parallel. Or we need this angle and this angle to be equal. That also means they're parallel. So in this case, they are. And let's see, Renetta, if you are currently watching, this is one of the topics that I am going to cover from you today as well, just to show you that a lot of these courses have overlap. When I get onto the Math 2017 section, we are going to be talking about this same topic, just all we're going to be doing is labeling if they're corresponding supplementary and stuff like that, right? Next up, oh, sorry, that's not B, that is C. That is C. Boy, put a C there. All right, so never mind then. That was question C. Question B, we're going to do B for real this time. I'm going to do that one over here in green. Draw this guy down like that. So for this one, we have got 113 degrees here, and we've got 113 degrees here. Now, again, this is a good time for us to get some of the angle properties, right? So we know that if there's a cross, if two lines cross, the ones on the same side of the straight line have to add to 180, but the ones on the opposite side of the straight line have to be equal. And why is that? Well, if we go back and look at this guy over here, say I treated this as a straight line there, and I got that one to be 94. If I treat this as a straight line here, I can do the same thing again, and this one here is also going to work out to be 94. So one consequence of the straight line being 180 is also that the opposite angles across like that are going to be equal. So this one here now we know is 113. This one here is 113. Right? So now we see that these angles are indeed corresponding. Look at that. This is 113, this is 113. That means B is indeed parallel. Right? We can also figure out these angles over here, of course, with 180 minus 113. So this is going to be a 67. This is going to be a 67. So is this, and so is this. Right? And now question D. Let's do question D in red over here. So that one sort of slides in from the side, like so. So for question D, we've got 138 degrees here, and we've got 41 degrees here in this sort of section. So again, right, to determine if it's parallel, we have to determine if the lines are the same. So this is 138. 180 minus 138 is going to be 42 degrees. Wait a minute. 42, 42, 41. Those aren't the same. Those aren't the same at all. So we know that D now is going to be not parallel. Okay. So that was, I believe, Captivating Cacti, the question that you wanted me to get to. Yeah, because there was another question on the page, but I didn't have all the parts to answer that one because I needed the diagram off to the side. I hope that answers your question well. If you've got anything else for me to get to, again, please let me know. You can let me know during the stream. I will try to get to it as quickly as I can, and if I can't get to it on that stream, I will always get to it the next day. Get a few spoonfuls of my delicious soup, or paste, it's more like. It makes it nice and thick, boy. Oh, it's thick. Nice, sunny boys. Yeah, some thick pea soup. So, that was Math 2101A gone. Next up, seeing I just talked about it, and seeing it's the same sort of topic, I am going to pivot to Math 2017. Just went over that one verbally. Just mentioned that I was going to deal with it. So for these guys, unfortunately, I don't have a digital version of the text. It's these Prism Math. They're a reasonably good textbook, honestly. They have a good order of topics, and they work through them very painstakingly and bit by bit. Right, which I do kind of like. I like how it introduces stuff very gradually. Because very gradual, that's sort of my MO, as you can tell by my cadence. Okay, Math 2017. So Renetta, you've already finished these ones and submitted these, so I'm going to go ahead and just show it to you with the answers here. But we're going to talk down through why these are what they are. Now let me see if I can get this guy a touch closer here. Again, as my title says, my document cam is slightly less blurry than the Loch Ness Monster. I would just, one of these days I'll get a better document cam, but for now maybe, going around to the electronic stores is not the wisest choice. But, we're all making do. It's totally fine. So, name an angle that is opposite to B. Opposite to B is H. All opposite means is it's across from it. Now, I don't think I have a pencil here, so I can't really write on my book because I don't want to make a permanent pen mark on my book. I do not see a pencil here in my desk drawer. So, I'll just point with my triangle. So name an angle that is opposite to B, that's going to be H. Opposite means it's across the triangle from it. Name an angle that's supplementary to D. Supplementary to D is either C or E, right? C or E, because supplementary means it's the same straight line. You know how I was just talking about how straight angles in a straight line add to 180? Well, that's what we're talking about for C and D here, right? They add to 180. D and E also add to 180, so we call those supplementary. Two supplementary angles add to 180 degrees. Name an angle that's opposite to F. Opposite to F is D, right? Opposite again, just to cross the angle. Opposite, cross the angle. Supplementary adds to 180. All right. So it's just really a terminology sort of question, right? I also wanted to mention page 162. I'm going over these a bit quick, right? But you have already submitted this topic. You did really well on the course. You've already got your grade, I believe. And after the stream is over, I will link you to the video of me talking about these. Okay, just hold on one quick second. Okay. So now we're over to another topic, which is transversals. So this is the same sort of deal as before. Name the parallel lines are LM and NP. Now, unfortunately here, they don't actually, I'll even write this in pen. I'll write this in pen because this really should be there. This is a teachable moment for the people that wrote the Prism math book. All right? If your lines are parallel, they should have arrows on them thusly. Like that, right? Two lines that both have the one arrow are parallel with each other. Then we'll use two arrows to denote other lines that are parallel, right? So by rights, that really should have had that. So if you missed up this one, I'll let that one slide, right? Because the book really should have denoted it with those. And if you're drawing out lines, I will expect you to show parallel lines using arrows that are sort of like on the middle of the line. Right? The transversal is QR. Transversal just means a line that crosses over the other lines. So QR is the one that's crossing over these two ones. Angle that corresponds to 2. Now, here's where we get the stuff. Angle that corresponds to 2 is 4. A corresponding angle is sort of that angle that's in the same place, but on a different pair of lines. Right? So LM and NP are parallel, which means all the angles around them will be the same if the other line is the same, right? And since QR is the same line here as it is here, it doesn't curve or turn or anything, it's perfectly straight. That means that 2 is going to correspond to 4, which means the two of those angles are equal. Number 3, angle that corresponds to 3 is 1, right? Corresponds to 5 is 7, corresponds to 8 is 6. Right? And it's sort of the same deal down here. The parallel lines are these two. Transversal is UW, and 3 corresponds to 7, and so on. Okay, so that one is kind of just a terminology question, really. I believe I was asked to cover something else in that book. Let me see here. Math 2018, page 173. So I'm going to go over that one there now. Math 2018, page 173. Now, this is a topic that there's going to be a lot on. So for tomorrow, actually, I will put a pin in this, and I will prep just some other work on this same topic. If you're ever looking for extra work, check down below in my FAQ. Right, you'll see that I mention Khan Academy and MathAids.com. MathAids.com is a fantastic place to get procedurally generated worksheets that'll have like as much practice work as you could ever need. The only difficult part is you have to know the name of your topic, but I can tell you the name of the topic, or I can even link you to the page if you really want extra work, right? Extra practice work. And believe you me, circumference and area of circles there's loads of that. So we're going to see these more than a few times for sure. So let me go over now. Find the approximate circumference of each circle and use 3.14 for pi. Like I've said before, I ain't about this 3.14 life, but we'll stick with it because that's what we're being told to do. So this is Math 2018, page 173. Okay, so for question 1 then, the approximate circumference. Well, the circumference of a circle is just pi times d, or 2 pi times r. Right? C is equal to pi d, right? And we know that d is equal to 2r. So I mean, therefore, it's pretty easy to see that c could also be equal to 2 times pi times r. We usually put the 2 first. That's just how it's read. But, you know, it doesn't actually matter because multiplication is commutative. That's right. We covered that. Was that yesterday? Yesterday or the day before? We did cover commutative, that term. Yep. So we're breaking it back out, right? It's callbacks. It's good stuff. It's good. It's the bread and butter of any comedian, let me tell you. Just callbacks. You make one good joke, and then you just sort of blather on for a while, and then reference it again when people have forgotten about it. So let's see here. Circumference is equal to pi times the diameter, which is 21. So we're going to use 3.14, like the, you know, we'll acquiesce to what the course is telling us. So we're going to do 3.14 times 21 equals, kapow, done, easy. 65.94 centimeters. Now the circumference is the distance around the outside. Actually, let me get rid of, let me just get a white screen up here. There we go. Just blank that guy out because we're not dealing with that right this second. So the circumference is the distance around the outside of the circle. So that's the circumference. That is 1A. For 1B, this is one of the other ones that I want to show you an example of. The only difference here is that they give us the radius, right? Because as you see here in this picture, the line that we're dealing with is from the center to the outside, like so, right? And the radius is what that is. It goes from the center to the outside. A circle is actually a function of the radius, right? Because a circle is all the points in 2 dimensions that are the same distance from a center point. And that distance is the radius. Right? So in many ways, the radius is a more important measure for a circle than the diameter is. But either way, getting off topic here now. So here we have circumference is equal to 2 times pi times the radius. So circumference is equal to 2 times 3.14 times 7. So it's equal to 2 times 3.14 times 7, 43.96. 43.96 centimeters. Did I get those? There we go. Yeah, about 44, about 66. Sure. Cool. We're doing it. Right? And that's really all there is to circumference questions. Right? Yeah, they're not, it's not a super complicated topic, but it is the kind of thing that we're going to build on a lot as time goes on. Like you will see quite a bit more because this same sort of thing, this is used when you get into surface area. You talk about cylinders, you talk about cones, you talk about spheres. Well, spheres are a touch different, but it's all based on the same kind of thing, and it uses the value of pi, pi being a super important number. And I'm actually kind of disappointed in myself because I missed Pi Day. Pi Day, and March the 14th. I should have had like brought in an apple pie or something to work, and then did some kind of silly lesson about how we derived that. Played the Hard and Firm song. It's, you should seriously, like it. I mean, that was dank before dank was dank. Let me tell you, the Hard and Firm pie song. It's good. Like look that up on YouTube sometime. Let me tell you, it is noodle boiling. What was the other thing that I wanted to cover? Yes, Renetta, seeing you asked for circumference of a circle, I figure that I will mention area of a circle as well, just because that is a similar one. So here we go, area of circles. Not to show off all the solutions, Hold the phone. Hold the phone. Just a cotton pick a minute. Going to do some paper crafts here, so that when I send Renetta notes, I don't need to take pictures of a whole bunch of different pages. Flip it open and stick this guy over here. So 1A, find the approximate area of each circle below, and again use 3.14 for pi. It's unfortunate, but you know, you got to do what you got to do. Area of a circle is equal to pi times the radius squared. Now, it's like I was just saying, the radius is often a more important fact about the circle than the diameter would be. Here, the radius is 3, but it's super important that we use the radius for area and not the diameter. Right? And it's important to know that this is radius squared, which means radius times radius. Sometimes it's also written as area equals pi r. And this book, as we see right here, this book does indeed put the 2 r's out there. Because like I said, Prism Math is fairly, it's pretty good in how it doesn't assume that people know a lot about math already going in, which is a really useful thing in a program like we're in. It's one of the main problems with some of the textbooks is that they assume that students have sort of like perfect total knowledge of past topics, and it's just not the case. It is absolutely not the case. And when people are working through it on their own, it's really difficult for the teacher to necessarily say, well, the reason the book skipped that is because the book thinks that that was a previous lesson that you covered in a previous year, right? It's kind of like the meme that you'll see, right? People will be like, oh, the teacher says, oh, don't worry about that. You're all gonna cover that next year. And then when they get to the next year, the teacher was like, well, we're not going to worry about that because you should have covered it the previous year. It's kind of the same thing that's going on here. Anyway, I'm rambling at this point. 9 pi is going to be about 27. It's going to be exactly 27 because pi is exactly 3. Right? It's a Simpsons reference. 28.26. Meters squared. Square meters. Square meters because it's area. And then 1b over here, right? This one, again, we've got area equals pi r squared. Now, it's super important over here, like I was saying, that we take this 18 and we turn that guy, we turn that guy into the radius, because that's the diameter. We know that diameter equals 18, which means radius equals diameter over 2. So radius is going to equal 9. Super important that we do that first, because the answer will be just way off if we don't. Area is equal to pi times 9 squared. So the area is equal to 81 pi. Sometimes in later courses, you'll see it just left like this. We call that in terms of pi. I was talking about that yesterday. But for now, we're just going to use 3.14 for pi. So we're going to do 81 times 3.14. Click enter. 254.34. 254.34, and that was centimeters and squared. It's always squared because centimeter squared is a unit of area, right? A centimeter squared is an area that's 1 cm by 1 cm, and that's 1 cm squared, right? So that's hence the 2 in the corner. So that, Bernetta, is that was the Math 2018. What you asked for me to cover, and then another little bit that I thought might be useful for you to know if you needed some pointers on the other one. Now, what else have we got? We got my lovely padded background here. Actually tweaked the color balance on my dock cam mic. My dock cam. Hopefully it's a little bit more legible for y'all. Let's see, what do we got left? We've got Math 1102A, and we have got Math 1101C. I'm going to switch over to Math 1102A right now, I think. Yeah, that sounds good. That's 1102A. Let's bring that up over here. So we're back over to this guy. We were looking at this guy a bit yesterday. We're going to cover a few more topics on this one today. So Ashley, if you are watching right now, yeah, this is going to be ones that you submitted. And if you're not watching right now, hello, future Ashley. I hope this helps. So, 2A Unit 2 review, 6B. Let's start off with 6B. Ah, okay, number 6. Number 6 here. Determine the perimeter of the figure in inches and in feet and inches. Okay, so let's zoom in. Let's keep the cam up there in the corner. Let's zoom on in. Zoom on in. No, let's keep on going. Come on, mouse. You can do it. Oh, no, zoom out. Zoom out. Okay, we're going to have to move in over slightly. There we go. There we go. Yes, boy. Marvelous. Okay. So this is Math 1102A, Unit 2 Review. Okay, so first up, we got to get the perimeter of this figure. Now, perimeter is just the distance around the outside, right? So this is going to be 6A. We can see quite clearly from this figure, right? This one over here. We see in my cursor? No, we're not. There we go. There's my cursor. So we can see quite clearly most sides of this figure. We got this side, this side, this side, and this side, 9, 28, 17, and 15. So I'm going to go ahead and put those in here. 9 plus 28 plus 17 plus 15. But an eagle-eyed viewer will be aware that we ain't got no number here. Ain't got no number here. What do we do? What indeed do we do? Well, what I'm going to do, we can figure out this number by doing this one minus this one, right? Because we know that the whole left-hand side, so this plus this, has got to equal the right-hand side, which is this. So we know that this guy here is going to be 17 minus 9, otherwise known as 8. So I'm going to go ahead and add an 8. And it's going to be the same thing for this one across here, right? That's going to be 28 minus 15, so that is going to be 13. So now we're going to go ahead and add all those up. That is going to be, let's see, that's going to be 37. So that's going to be 54, 69, 77, and 90. 90 inches. Okay, so that one's fairly straightforward, I think. And yeah, because the only wrinkle there was that we had to remember that we're going to need to find the other ones. But when we go on to B, B is a bit odd, especially odd for us Canucks up here in the Great White North, because we're not used to this imperial nonsense, right? Because if they ask you to convert this to feet, you might think, well, I know there's 12 inches in a foot, right? I mean, so what I'm going to do is I'm going to do 90 divide 12, right? And then I'm going to see what I get. So let's bring up ye old calculator. 90 divide 12. It's going to get us 7.5. So that's 7.5 feet, right? So we know that. It is 7.5 feet. But then sometimes people will write that out as 7 feet 5 inches. Very frequently, people will write that out, and it's not. It is not 5 inches. No, it is not. No. Why is it not? Well, there's 12 inches in a foot, right? This is 7.5 feet, 7.5 feet. What's half a foot in inches? Well, it's going to be 1 over 2 times 12, which is equal to 6, right? So we know that 7.5 feet is actually 7 feet 6 inches, like that. Right? Very small difference, very small, but it comes up pretty commonly. Oh, my food is calling to me. Mm. Mm. Oh, one of my remaining pieces of pulled pork in that bite. That is good. Although it's a bit cool now. It's not quite so warming. If this were the long dark, I would no longer be getting a warming buff from eating that stew. So maybe I need to go nuke it again. Uh, question 8. Find the length and girth of the given figure. Length and girth. Boy, we got some girthy figures over here. That's a lot of girth coming around. Um, boy, oh boy. It's not a term that is used a whole lot in these geometry courses, partly because I don't know. It just very rarely comes up. It does come up in this course though, and it is worth knowing that all girth means is the perimeter of the end of a shape. How do we tell what's the end? Well, especially of a regular shape, right? The end is going to be the narrow bit. Like, sorry, you don't get extra credit. You can't find my day 2 clip. Yeah, Brittany. That one accidentally got named as day 1 again. So the day 2 clip is the second one that's listed as day 1 because I started the clip off calling it day 1 and then I changed the title like part way through, and for whatever reason it doesn't come back saying day 2 on there. I am going to see about editing the names of my past broadcasts. I'm sure there's a way to do that. I just haven't seen it yet. If anyone out there is a Twitch wizard and you want to tell me how to do that, please, yeah, drop that one in chat or send me like a tutorial on an email or something. Pretend I'm a boomer and you just got to talk me through every last thing. Like take a picture of every step that I would have to go and tell me where to go because I'm, you know, like I said, I'm an internet dad. Yes, there are 3 videos. That's right. Yep, one from day 1, one from day 2, one from day 3. Today's video is not up yet. It'll be up when the stream is over. Right? So there should be a day 1, another day 1, and a day 2. But just mouse over it, mouse over the video, and it'll tell you what day it was posted. So if you're looking for day 2 video, you'll be looking for the video from March 24th. Okay, and that is in the videos sort of category on my Twitch, which will be up. Oh no, no, not that way. Why am I finding it so hard to coordinate this? Why am I finding it so hard to coordinate pointing? There we go. Like that way. Like that, right about that direction. Yeah. Sort of. Actually, no, I tell you what. The video, it'll be sort of like here. There we go. There we go. Right about there. Right? Is that right? Yeah, I got it. Look at that. Ah. Yeah, look at this technology. Mm-hmm. That's good. That's good content. Anyway, back to girth. Back to the girth. Girth is the perimeter sort of the end of the shape, at the narrow end. Like I said, you don't get to cheat, you don't get extra credit. You got to take the narrow end. So here, the end that we're dealing with is going to be this one over here, which is 5 feet this way, 9 inches this way, right? And it's important. What we're trying to find is the perimeter of sort of that end, which will be down here, which is 9 inches that way, and it's going to be 5 feet that way. But we can't add inches and feet together like that, right? So we have to know that we can either convert this one into inches, and call it instead 60 inches, or you can convert this one into feet and call it 9 over 12 or 3 over 4 or 0.75 feet. Whichever one works for you. I'm gonna, unless your question specifies if it wants fractions or decimals, I'm gonna take either. Right? So here I'll just do it in inches. I'm just going to convert the whole thing to inches. So it's going to be 60 inches on the bottom, 60 inches on the top, 9 inches on the right, 9 inches on the left. So then your girth is going to be 60 plus 60 plus 9 plus 9, which is going to be 138 inches. There you go. Right? That was, I believe, the only thing that students struggled with on this one. But then, because it's around the narrow end, the length is just going to be the other value that you didn't use to determine the girth. So the length is just going to be the 8 feet. Right? That's all there is to that one. It's more of a terminology question. and a pun question. Um, Question 11, the next one I wanted to go over, yes. Mary wants to put a wallpaper border around the walls of her bedroom. Let me zoom out so y'all can see it. Bedroom measures, oh, not zoomed out enough, hey. Zoom out. Zoom out again. Mary wants to put a wallpaper border around the walls in her bedroom. The bedroom measures 11 foot 6 inches by 9 foot 8 inches. Calculate the perimeter of the room and express your answer in feet and inches. This one is, yeah, it's quite a lot easier than it might sound at first. Question 11. Actually, no, let me switch back to black. Back to black. I hit the sack. Gotten so long, I'm glad to be back. Okay, so the bedroom measures. Just put a border around the walls. So yeah, so looking down from the top, here's our, this is the bedroom. I'm going to use this as if it was a stencil, just to do out a quick pow pow, like that. Look at that. Okay, so we've got 11 foot 6 inches here, and we've got 9 foot 8 inches here. So we just got to find the perimeter of the room, right? She's going to put a border around the full thing. So all we're going to do is just double up this 11 foot 6 inches, 9 foot 8 inches like that, and just add all four of them together. Now, the reason I'm showing sort of this question here is because it's useful to show off the way in Imperial that will add these together. Because one of the only applications that you'll see of like mixed numbers and stuff is this weird ass backwards measuring system. Not to besmirch any, you know, Americans in the chat. You guys didn't invent it. You're just sticking with it for some reason. So anyway, we've got 20 here, 11 and 9, another 20 here, 11 and 9, so that is 40 feet. And then we can go ahead and add these guys. That's 12 plus 8 is 20, and that's 28 inches. But the only other wrinkle, like the only other way that you could lose a mark off of here is sort of by leaving it like this. Because we never, if we've got a number here greater than 12, we always take out as many feet as we can. Because this, like I was just saying, right, mixed numbers, if we were to write this as mixed number, it'd be 40 and 28 over 12. Now you wouldn't leave a number like this, 40 and 28 over 12. What we're going to do is reduce this one down. So 28, I'm just going to put this bubble over here, 28 over 12, we know is going to be equal to 2 and 4 over 12. Right? We know that because 2 times 12 is 24, and 28 minus 24 is 12. Now, in our other courses where we dealt with mixed numbers specifically, by this point we would take this now and reduce this down to 1 over 3. But here we're not going to, because it needs to be over 12, because it needs to still be inches. So instead of 40 foot 28 inches, we're going to have 42 feet and then 4 inches. And that then, that's your answer. All right. All right, so that was 1102A Unit 2 review. Actually, I'll get you, let's link you to the video where you can watch those at your leisure if you weren't joining me on the trip down 1102A lane. Now I believe the other topic that I said I was going to get to today is going to be Math 1101C. So this is going to be Math 1101C and be Test 2. Oh, no. Scratch that, reverse it. I'm not going to do the stuff from the test on screen because then y'all would, it wouldn't be a surprise then, would it? No, that's right. So, let's see, numbers 5, 13, and 15. All right, okay, this is a good question. Question 5 here, yeah. Let's zoom in on this guy because this is going to get me using my Technology. Which, okay, got to go over here, scroll this guy back over. Which linear system is represented by the graph shown? Okay, so we've got four choices here, and we have to figure out which of these four makes this guy over here. Thankfully, in each of these, we have ones that are solved for y. The ones that are solved for y, right, are super easy ones to try to figure out some details about. Because say if we look at question A over here, right, let me see, was my cursor coming in? There we go. So if we're looking at, say, question A over here, we see this second line is y equals 3 over 2x plus 3, right? Which means if that line was here, there should be a line that crosses the y-axis at 3, and it should have a slope of 3 over 2. Right? So there is a line that crosses the y-axis at 3. We can see that right here. Right? See my cursor there? We can see that right there. So we do know that B and D are right out. Those are not, it can't be those. It can't be B and D because the line crosses at 3. So now we've narrowed it down already to A and C. And now A and C both have the same slope on this line, which is indeed 3 over 2. As we see, there's a rise, it's rise over run, right? So it's a rise of 3 and a run of 2. Go 2 right, 3 up. Checks out. So now the other two are x minus y equals negative 7 or x plus y equals negative 7. Well, on a test, what I would recommend you do at any point like this is put these back into a form that you are used to working with. And now personally, I'm most used to working with the good old y equals mx plus b. I like that guy because it tells us some of the most relevant information about the line just right up there on the front. Right? You don't necessarily need to have remembered every single different form of a line and what the parts represent. You just need to have the basic algebra skills, which hopefully I'm helping you build through all the courses. You just need to have those skills to be able to rearrange this stuff. Right? So then let's rearrange the one in A. Right? So the one in A is x minus y is equal to negative 7. Right? So if we move, I'll move the y over here and the 7 over here. We have x plus 7 equals y. Right? If this was a line on the sheet, then the slope should be 1 because there's, basically a 1 here, and the y-intercept should be positive 7. So if you look back over at our, here we go, look back over at the graph, is there a line that goes through positive 7, which would be up here? No. This line appears to be going through negative 7. So it seems to me the answer we need is probably C. Also, we can see that this line has a slope of negative 1. The line that we have found here, this would have a slope of positive 1. So this is absolutely not that other one. We already know the answer is C. But just to show you, using the y equals mx plus b, how we could tell that, right? So we have x plus y equals negative 7. We would have y equals negative x minus 7. Right? The x just moves over, super simple. And so now we know that this line would have a slope of negative 1, which means it would go down 1 when it goes to the right 1. Over and look at this guy. Right 1, down 1, right 1, down 1, right 1, down 1. Hey, checks out. And we can clearly see that it will cross down here at negative 7. So our answer here is C. Right, now I wanted to go on to question 13. Question 13. Solve the system by elimination method. Wonderful. This is good stuff. Zoom in. Okay. Solve the system by, oh, that's not the way I wanted to move that. Solve the system by elimination method. I'm going to zoom in a bit closer to the system itself. So this is question 13. This is a good one. I mean, these are all good ones, right? Every math question is a good one. We have 3x plus 5y is equal to negative 2. Then over here we have 2x minus 4y is equal to positive 7. So in order to solve it with elimination method, what that means is we want to get either the x's or the y's to have the same coefficient on the front of them, right? So we either need to multiply, we'll multiply basically both sides of the equations by the same number. So I'm going to multiply this whole side by something, and this whole side will be by the same thing. Same with down here. And the goal after we're done is so that either the x's or the y's will have the same coefficient on the front. I'm going to get the x's to cancel. So I know that the lowest common multiple of 3 and 2 is going to be 6. Just know that one. It's in both of their times tables, of course. So I'm going to go ahead and multiply these so that the x's will have a 6 on the front. There'll be a 2 there and a 3 there, 2 there and a 3 there. So then we're going to have 6x plus 10y is equal to negative 4. Here we're going to have 6x minus 12y is equal to 21. Right? And I'm going to head now and subtract these guys. So 6x's minus 6x's is 0x's. That was the point. I'll just write it out here just to make it clear to everybody. Here now we have 10y's minus negative 22y, which makes positive. Sorry, I just misspoke and sort of tipped my hand. 10y minus negative 12y is going to be positive 22y. Then we have a negative 4 minus 21 is going to be a minus 25. Now, I've said before a whole bunch of times that oftentimes on a test or on an assignment or on an exam, you'll be tempted to metagame something and think, hey, if I'm coming up with some like decimal that doesn't cancel, I got to be doing it wrong, right? Because the teacher definitely meant for the answer to be like 5 and not negative 25 over 22. But guess what? Sometimes y does equal negative 25 over 22, and it's all you can do about it, right? So now that we have this to be our y, right? One thing you can do, I mean, if you're unsure, like I would be unsure if I saw this on a test. Absolutely, for sure I would be. Yeah, 100%. So what I'm going to go back is I'm just going to go back now and make sure that all these ones were multiplied correctly. 2 by 3 is 6, 2 by 5 is 10, 2 by negative 2 is negative 4, 2 by 3 is 6, 2 by negative 4 is negative 12, or sorry, 3. 3 by 7 is 21, 6 subtract 6 is 0, 10 subtract negative 12 is positive 22, negative 4 subtract 21 is negative 25. All right, checks out. So now I'm going to go back and stick this guy up into one of these ones. So I'm just going to do, let's do the second one. So a little bit will cancel. 2x minus 4 times negative 25 over 22 is equal to 7. So that's 2x minus, well, 4 over 22 is the same as 2 over 11. 2 times 25 is 50, so it's going to be plus 50 over 11 equals 7. So 2x is going to equal 77 over 11 minus 50 over 11. So 2x is going to equal 27 over 11. So x is going to equal 27 over 22. And there we have it. Again, right? Like, it's easy to see something like that and be like, wait, there's no way that was the right answer. What is this nonsense? But here it is. Point of intersection is 27 over 22, negative 25 over 22. Yeah. It's how it breaks down sometimes, boys. That's how we do it. Number 15 now. Number 15. Let's do that in another color. Do that in green. Let's stick it over here. Now, 15. Oh, no, that's the zoom in button. I need the zoom out button. Frankie. Oh, have I got, was that messages? Oh, no, no, that's a phantom vibrations. Phantom vibrations. Zoom out. Give it a touch more. Yeah, it's kind of a small one there, isn't it? It's hard to see that. Uh, it is a bit hard to see. Frank sold 10 adult tickets and 6 student tickets to a concert and collected $168.50. Mary sold 8 adult tickets and 12 student tickets, and she collected $187. Set up a system of equations and use it to determine the cost of both types of tickets. Okay, so Frankie sold 10 adult, got 10A, and six student, and he got 168.50. 168.50. Tree fitty. Ain't giving you no tree fitty. Loch Ness Monster. We've got 8 adult tickets, 8A, and we have 12 student tickets, 12S from Mary, and that is going to be 187 bucks. $187 dues. So does it tell us how to solve it? No, it doesn't. It doesn't specify. Great. Great. So I'm going to go ahead and use elimination method because we've got a 6 here and a 12 here, which means I can easily just double this sucker and double this sucker, and we're going to get it. Right? So if I take that one and double them, we've got 20A, and here we've got 12S, and that's going to equal, and this is going to be doubled, so double 160 is 320, double 8 is another 16, so 336, and double another dollar, so that'd be 337. Right? I'll just multiply it on my calculator, 68.5 times 2. Yeah, there we go. I always talk through mental math, not to try to be like, oh, look at the math man over here acting like he's got like a calculator built in or something. But mental math is entirely about finding shortcuts to do arithmetic easier. It's not about being like super smart or being able to do a whole bunch of stuff in your head at once. It's about being lazy. It's about finding the easiest way to solve something, right? That's kind of what this whole new math thing is about. You might see like Facebook memes of people being like, "Why are they telling our kids to like break down these numbers into adding? We did it the long way and we're fine." Yeah, the long way works great, like on paper, but breaking it down into smaller things and doing easier versions of arithmetic, that's what goes on in your head. And it looks foolish to write it out on paper, but it makes sense when you realize that it's not meant to be written out on paper at all. Anyway, so I'm going to go ahead and subtract these guys. I'm just going to subtract it like that. Now, I could flip these around so I wouldn't have to deal with negatives and subtract this one from that one. But I'm just going to go ahead and subtract it as written. There's going to be a negative, but it's going to cancel, so who cares? It's going to be a negative 12A, right? Because conceptually, like would never have a negative number of tickets. That's kind of silly, right? But this is going to be what, 150? It is 150, right? So minus, yeah, negative 150. So A is going to be 150 over 12. So A is going to be 12.5. So now we know that the cost of the adult ticket was $12.50. So now I'm just going to go back and substitute this into one of these guys. Want to become famous by fall? How about... Oh, timed him out for 1 second. Oh no, I didn't want to time out for 1 second. I wanted to ban that one for permanent. Like if they come back, we're gonna nuke that one again from orbit. Okay, where was I? Right. So 10 is 12.5 plus 6s equals 168.50. Right, so we have 125 plus 6s equals 168.50. 6s is going to be 168.5 minus 25, which will be 4350. So S is going to be 4350 divided by 6. I ain't going to do that one in my head. 725. There we go. There we got it. Oh, I was off. I was scrolled down. Y'all couldn't see that one. Okay, so determine the cost of both types of tickets. Well, cost of those tickets. Cost of those tickets is going to be $12.50 and $7.25. Okay. So that was 1101C. Okay. Good stuff. Good stuff. Another bite of my food. Still haven't eaten my lunch. That's good. So now what I'm going to go over, I'm going to do a bit of another topic here as well. We have got, let's see, got another one that I'm going to bring up. It'll just take me a quick second because now I've gotten to all the ones that I had queued up to do. If you're in chat and you've got any other questions that you want me to cover, you can feel free to drop those in. But I am going to go until 2. So I'm going to go grab another one that I was intending to do tomorrow, but now I will do it today instead. So put that guy over here. Going to do some probabilities. Good stuff. Everyone loves probability, right? I do. Probability is one of the best topics. So Esther, if you're watching this, these are ones that that I'll be covering for to link to you momentarily. I will send you the link after the stream is over as normal. But please do watch live and you know, come talk to me. It's a little bit lonely. It's a little bit lonely just sort of rambling to a screen on my own for, you know, 2 hours or so. So if you got something to say, you know, drop it in chat and let me know that there's life out there on the other side of the internet. But this is Math 3102A. I can see it. I can see there's some people watching. I know that. And yeah, I mean, y'all have definitely been appreciative, and I'm super glad that I'm helping people by doing this, right? So number 14. An ice cream store sells sundaes. There are 3 choices for ice cream: vanilla, chocolate, and strawberry. These are 3 choices for toppings: sprinkles, Oreos, and Smarties. Draw a tree diagram. Well, a tree diagram. Now, I am from Newfoundland, but I'm not saying, I don't mean 3. You know, sometimes when we say tree, we means like tree, right? Like, you know, sometimes it means tree like a ver tree, like out back. Sometimes it means, you know, a diagram. This time it means a diagram. So, first up, we're going to have choices for the ice cream. Then second, we're going to have choices for the toppings. So I'm going to write out ice cream here. All right, so we are going to have the 3 ones that are vanilla, chocolate, and strawberry. Good basics. Good stuff. It's Neapolitan. I don't know, did Neapolitan ice cream actually originate in Napoli? Quick, somebody in chat, Google that one. Vanilla, chocolate, and strawberry. This is ice cream, or we could say, we could just call this choice 1. That's how we'll call it in general. But this is the beginning of our Venn diagram, right? So I will just now go and see. I'll start my point here. So we go like that. We go like that. And then we go like that. Okay. So let me. Oh boy. I also need a new office chair. This one, the like the hydraulic thing that's in the center of it is kind of giving out a little bit. Like I'll be in the middle of some sort of high paced, Alterac Valley match where I'm, you know, putting the whole weight on my back and carrying it with my amazing healing. You gotta do what it takes, man. You gotta be out there. You gotta be. But healers carry hard in Alterac Valley. Let me tell you something. It's not because I'm good. It's because the role is important. It's also because I'm good. As I was, it's like it was. Anyway, you might see that on Friday. I don't know. I'm thinking about it. I'm thinking about maybe we'll do some after work, some after. Well, it's my second job, really. Anyway, um, so then we go on to our toppings. So our toppings are over here. Let's do those in a different color. Do those in blue. So this is going to be toppings. Choice 2, right? So then in each case, we're going to have sprinkles, Oreos, and Smarties. So sprinkles, Oreos, and Smarties. Right, and like before, I'm going to abbreviate these ones. So we'll call this SP, O, and SM, and then we'll go SP, O, and SM. Now, from each of these, right, we're going to have the lines going up, right? So we're going to have this here like that. It's like this, and this like that. Like so. All right. So now those are our ice creams, those are our toppings, and now over here we're going to do out our sample space because it always says list the outcomes, right? It's important. It's a super easy step to do, but you'll lose a mark if you don't do it. Like why miss one of your 3 marks? Because you'll get 1 mark for sort of doing this section, 1 mark for doing this section, and 1 mark for this section. Outcomes, or we also call it the sample space. Sample space meaning all the possible results. So here is going to be, like before, vanilla, comma, sprinkles, vanilla, Oreos, and I'm going to start abbreviating now. V and SM, C and SP, C and O, C and SM. I'll use ST for strawberry and sprinkles, strawberry and Oreos, strawberry and Smarties. There we go. Oh, actually, this is good. This is a good, not really teachable moment. Not, excuse me. Not really a teachable moment so much as a rambleable moment. I like those too. Um, Smarties in Canada are M&Ms, basically. Smarties are chocolate that's covered in candy, right? In the States, I believe, Smarties are these sort of small, chalky, like fruit flavored things. Here, I'm pretty sure those are what we in Canada call rockets, right? So if an American thought of like, why would you add Smarties to like vanilla ice cream? That just sounds like it's going to be kind of pasty and weird. No, but it's just they're just nice little crunchy pieces of chocolate with candy on the outside. It's delicious, right? Now, if you added rockets to vanilla ice cream, I'm not sure how that's going to go. I think once that starts to melt a little bit, it's going to get that's going to turn into a proper mess. But anyway, 14A, that is 14A done. So now, what is the probability as a percent you select a sundae with vanilla ice cream and Smarties? There we go. This is a good question. There's less of it in this course, as you're seeing, but the topic is very similar to stuff that I covered earlier in this same video and in other videos, right? So Esther or anyone else who's watching this to see stuff from Math 3102A, um, it could be a good practice to go back and check earlier parts of this video as well, because it will cover the same topic, but just in a bit more detail. But here what we have is the probability, right, that we're going to pick a sundae with vanilla ice cream and Smarties. Well, the probability of anything is always the favorable outcomes divided by the total, right? We know that. So what are the favorable? What are the chances that we get vanilla and Smarties? Or how many of these results, rather, are vanilla and Smarties? It's just this one. It's just that one. It's not vanilla or Smarties. It's vanilla and Smarties. So the probability that was vanilla or Smarties is going to be 1 out of a total, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Done. Probability is 1 out of 9. So imagine that there was a question C here. There's not. But imagine there was, and it was the probability of vanilla or Smarties, right? This one here was and, this one here is or. So imagine it was that instead. I'm going to go ahead and put some arrows onto the end of these, just so we know. So vanilla or Smarties. Well, how many are those going to be? Well, this one has vanilla or Smarties, right? Because it has vanilla. This one has vanilla or Smarties. Or actually, I'm just going to go mark through. I'll mark the 3 vanilla ones with blue. So vanilla blue, right? And then Smarties red. Because when you eat your Smarties, do you eat the red ones last? Do you suck them very slowly or do you crunch them very fast? Pretty sure that was the next line. That's yeah, just random 1990s like Saturday morning cartoon commercials. Boy, oh boy, there's like a whole section of my brain dedicated to those, and I just can't get rid of it. Smarties here, Smarties here, and Smarties here. Right? So if we're looking for the probability of vanilla or Smarties, well, we've got 3 for vanilla, 3 for Smarties. Does that mean there's 6? No, there's not. No, because I mean, I've done this lesson like what? I've been doing this stream for 4 days now. I think I've done this lesson like 6 times already. But something worth mentioning every time, if we have vanilla or Smarties, that's equals PV plus PSM minus PV and SM. Right? Because it minuses the overlap, so it's going to be 3 plus 3 minus 1, or it's going to be 5. And that makes sense, right? Because if we went and just sort of circled all the ones that have at least 1, but it doesn't matter if they have 2 or more, it's still the same. It would be 1, 2, 3, 4, 5 outcomes. Okay? And that question doesn't actually exist in this activity, but if it did, that would be what we would do. So I'm just going to put a bubble around this guy. So this is sort of like a bonus blathering. Yeah, Blathers from Animal Crossing. It's kind of like my spirit animal, hey, or spirit anthropomorphized animal character. I don't know. Does it count as a spirit animal if it's already like turned into a person? I don't think that counts, right? Like it has to be actually an animal to be a spirit animal. I wouldn't say an owl is my spirit animal, not really. No. Maybe like a chubby golden retriever. Mm-hmm. Who like, just dies for like peanut butter and chocolate. Sort of that's sort of my jam, right? That's sort of me. Yeah, so I wanted to do question 15 as well. Raymond, bought a Raymond. No, Deborah, no. I do like three impressions, and one of them is Ray Romano saying those exact words. No, no, Deborah, no. Raymond bought a bag of bulk candies. He counted them and found that 15 were red, 10 were green, 12 were purple, and 13 were orange. Calculate the probability as a percent of a randomly chosen candy being red. Easy. Okay, no problem. So, obviously, of course, probability is always fave over tote. Fave over tote. So, what is our tote here? Well, the total is just going to be 15 plus 10 plus 12 plus 13. Plus 10 plus 12 plus 13. And that's going to give us 25, 35, 50. Okay, probability as a percent of a randomly chosen candy being red. Well, there are 15 of those guys, 15 red ones, out of 50 total. I'll write that over here. Favorable is 15. So it's just 15 out of 50. 15 out of 50 is going to break down to, of course, 30%. 30%. There it is. All right, Math 3102A. We're still doing it. We're still getting it. So that was part A there. B, what are the odds against as a reduced fraction of picking a purple candy? Now this one's got another wrinkle there. That's why this one's worth 2 marks. Right? That is actually a good like activity and test taking lesson, let me tell you. Is metagame it. Like totally see over here, like there's 2 marks. That means you probably gotta do twice as much work for this one as you do for that one, right? Say if it's like a biology test or something like that, or an English test, and you're writing up your long answers, and one's like a 1 mark question and one's a 2 mark question, and you end up with like a paragraph for your 1 mark question and a sentence for your 2 mark question. Guess what? You're gonna lose marks on the 2 mark one. You should always look at the number of marks it's worth and make sure to try to give your answer more detail if it's worth more marks. It's just basic sort of test taking skills, right? But anyway, 15B. Here we go. The odds against as a reduced fraction picking a purple candy. Well, we know that odds in favor are favorable compared to unfavorable. Right? Odds against, simply the opposite of that. Odds against are unfavorable to favorable. Like so. Right? So then, all we need to do here now is find out what the favorable and the unfavorable are, and then just plug it in. Right? So if we're looking for purple candies, right? 12 of them are purple. 12 of them are purple, so we're going to have favorable is 12. Unfavorable is going to be the rest of them, which is going to be 38. So the odds against is going to be 12 to 38. Never you mind the part, excuse me, where it says to do those as a fraction. Don't do that. Don't write your odds as a fraction. They're not a fraction, they're a ratio. Odds don't get written as fractions. Odds get written as ratios. But we can reduce a ratio down the same way that we reduce a fraction. That's totally fine. So we can divide both these sides by 2, and we can call this 6 to, was it 15 plus 6 to 19. Right? And this then, that then, this is the odds in favor. Yeah, but we weren't asked for odds in favor. What we were asked for is odds against. The odds against, of course, is just going to be 19 to 6. Right? It's worth knowing. the difference between odds in favor and odds against, of course, but they are just opposites of one another. And yes, this will be a good section to end with because these are super important questions that are used in a lot of different courses as well, not just this individual one. So I'm going to let me just reposition the old document cam a touch. I gotta say this desk lamp that I've converted it into a boom is great. This is one of the best. I've had this desk lamp I think longer than any piece of technology that's on my desk currently. I'm pretty sure. Yeah, that desk lamp is at least like, oh, it's a solid 15 years old for sure. Um, so let's see. This is still Math 3102A. And this now is question number 16. Question number 16. Here we go. So Laura rolled a die 20 times, and these is her results. So what is the experimental probability as a reduced fraction of rolling a 4? Good. This is the difference between experimental and theoretical probability. So the experimental probability is always based on the results of an experiment. Yeah, hence the name, right? Experimental comes from an experiment. It's not complicated, is it? So the experimental probability of rolling a 4, right? So how many times was a 4 rolled? A 4 was rolled 4 times. So that's going to be 4 out of, what is that? 4 out of 20 that she did in total. So as a reduced fraction, that is 1 out of 5. Right? Oh, that one's a bit, that one got ink spilled on it. There we go. Much better. Much better. Here we go. Probability of rolling a 4 was 1 out of 5. So what's the theoretical probability as a reduced fraction of rolling a 4? Well, what indeed? What is the theoretical? Well, this is a 6-sided die. It doesn't say, actually it just says die, doesn't it? It just says die. Hold the phone. Hold on a minute. Hold on, Twitch chat. Oh, we've gotten a lesson for now, let me tell you. Here we go. Here we go. See this? This is some serious nerd cred, is what that is. That's a. Let me just crack this one open. There should be some like cherubs singing. There we go. It's magnetic too. Look at that. Look at this. Look, listen to this. That's satisfying. This is one of my good friends gave this to me for Christmas. This was actually a group of us who play a bunch of games together. He gave each of us a dice log with a different combination of wood and colors of dice, which is quite nice. But look at that. That is good. But it says on this question, it doesn't tell us. It doesn't tell us how many sides the die has. Right? It just says Laura rolled a die 20 times. These were her results. Well, I guess we are to assume that it is one of these guys. One of these D6s, we call those. That's what us like hardcore nerds call this little cube here. That's a D6. We got ourselves a D4 here. Look at that. A 4-sided die. It's nice. Got a D8. Right? So say it was this die she was rolling. This one has got 8 sides. Right? So the theoretical probability of rolling a 4 on this guy is going to be 1 out of 8. Theoretical probability of rolling a 4 on this guy is going to be 1 out of 4, of course. When we roll a 4 is when a 4 is the one pointing up. Look at that. The theoretical probability of rolling a 4 on this guy is going to be 0. Why is that one going to be 0? Well, this one's a factors of 10, boys. Look at that. This is meant to pair with this other D10, right? So this is like a D10 times 10, kind of. And this one's a D10, right? So it's 1 out of 10 to roll a 4 on that guy. 1 out of 12 to roll a 4 on that guy, and 1 out of 20 to roll a 4 on the real boss man over here. This is the guy. This is the guy that determines. Yeah, that determines. This determines everything. Like this, D20 just rules the world, man. You get those 20s. You get those. Sometimes you got to confirm your criticals too, like confirming crits. What sort of similarity is that? I don't know. Like I've already rolled a 20, guys. Like I'm supposed to be critical. Supposed to get that double damage in here, right? We gotta feed it to me. That's the good stuff. That's what it's about. Anyway, so actually, I'll keep using my pretty dice. There we go. Number 4. So, what is the theoretical probability as a reduced fraction of rolling a 4? Well, since we are dealing with one of these guys, a 6-sided die, probability of rolling a 4 is a half, apparently, because I just did 2 trials and I rolled a 4 half the time, right? So does that mean that it's a half 50% chance? No, that was a random experiment. That was an experiment that happened to work out. No, it didn't work out. It didn't work out at all. And the reason it didn't work out is because I didn't do enough trials. But either way, we got there in the end. Theoretical probability as a reduced fraction of rolling a 4 is 1 out of 6, because there's 1 4 out of 6 possibilities. The experimental odds in favor as a reduced ratio, not as a reduced fraction, as a reduced ratio of rolling a 1. Okay, then. So let's keep alternating my colors whenever I remember to do it. So rolling a 1, then we have had, so favorable from our experiment is going to be 3 for rolling a 1. Unfavorable is going to be 17. Odds in favor, so odds in favor is a ratio of favorable to unfavorable, like so, right? So that means it's going to be 3 to 17. And as another callback to earlier, these are both prime numbers. They're prime numbers. They're numbers that can only be divided by themselves and 1. Only evenly divided by themselves and 1. Of course, they can be divided by any number. Any number can be divided by any number except 0. Okay, we've gone over that too. That makes for non-permissible values. For all you people like, I think Tia, who's currently doing that course, and Troy, who's not doing the course now, will be doing it very soon. I think he just did it. Anyway, my brain, see, it's just all these student names and courses just flow through in one side and out the other. They go in the eyes and like out the other end, you know. Okay. An employee at Stokes is unpacking glassware. The employee estimates that 9% are broken or chipped. Right, so this is the other type of question that we see quite commonly in these tests for whatever reason. These activities, these tests and assignments, and just the whole courses, right? So this will be I think this will be my last one for today, unless anyone chimes in Twitch chat. So if you're there and you're thinking about maybe asking a question of this, bespectacled, besweatered dork on the camera, please do it soon. And then I'll get to that today. If you do it afterwards, I'll get to it tomorrow. Employee at Stokes is unpacking glassware. The employee estimates that 9% are broken or chipped. Glassware comes in a box of 12. It's likely that a box will contain a damaged glass. Well, the way we determine if it's likely or not is we're just going to see if 9% of 12 is going to be around 1. So if there's 12 glasses, right? And then there's 9% broken. We're just going to do 9% of 12. So we're going to do 12 multiplied by 0.09. And what that is going to get us is 12 times 9 is 108. So that's going to be 1.08. Yep. So yes, indeed, it is likely. Is it likely that a box will contain damaged glass? Yes. On average, a box will contain 1.08 broken glasses. This, of course, does not mean that every single box has a broken glass in it, but it does mean that the average number of broken glasses per box is going to be a bit more than one. The store sells 400 glasses per month. How many cases should they order? I assume by cases they mean boxes. They would have to. They haven't spoken to us about cases. They have spoken to us about boxes. So 400 a month. So how many of those guys are going to be broken? Well, easy enough. We're going to do 400 times 0.09, right? 4 times 9 is 36. So it's going to be 36. We're going to have 36 broke in 36 broken glasses. How many cases should they order? Well, they're going to need a few more, aren't they? These 36, right? And this is a good point to talk about here just before we end for the day. If she was to order, if the employee was just to order an extra 3 cases, that would get the extra 36, right? But remember, those 36 are still going to have 9% of them broken, aren't they? Right? So we're going to need to do 36 times 0.09. And from that case, there's likely to be 3 more broken. Right? So if the person orders the 400 glasses and then 36 extra glasses, 3 more cases, in order to account for the broken ones, they're actually still going to be 3 glasses short because they're going to have the broken ones from this. So they're actually going to need to order another case on top of that, right? So if they do, so the 400 glasses are 400 divided by 12, which is equal to 33.3. So they need, then they'll need 3 extra, right? Which will get us up to 36.3. And then the other 0.7 of a set will be enough to account for those. So they're actually going to need to order 37 cases, right? Excellent. Okay. So that is a good look at Math 3102A as well. That's quite useful ones to have covered. Yes, thanks everybody for joining me on my trip of math discovery today. I am finally going to get around to finishing my lunch now that it's 2 p.m. Ah, that's good. It's real good stuff. Yeah, so as always, thanks for joining me. Please send me email if you're one of my students or any Academy Canada campuses. You have my email address already, and you can go ahead and fire off any questions that you've got, and I'll get to them the next day on stream. Okay. Yeah, appreciate anyone hanging out and dropping messages in the chat. Like to see it, like to keep me engaged as well. So I hope you find this service useful, and yeah, um, have a great rest of your day. Thanks very much.